Hello students, so welcome back to our YouTube channel. This is your Radha sir. Today we are going to discuss about electric current. Right. So this chapter I am going to discuss in 2 or 3 classes. So let us see the first class. So in this we have the first quantity is charge Q. Next quantity is electric current I. Next quantity we are going to discuss about potential difference V. And next one electromotive force. Right. So in this electric current, in this chapter, let us know about the first charge. Here every conductor, let us consider this a copper rod. So in copper rod it has a free electrons. Whenever the switch is on, then the flow of electrons will be there because of potential difference will be created. So let us see. Just this is the graphical representation of this is the flow of electrons in the conductor. Just for understanding purpose, we are considering this. In this rod, the electrons are flowing. So electron is nothing but negative charge particle. Charge. Charge is represented with Q, whether capital Q or small q. Charge is represented with Q. So we can see some of the charges in daily life. Electric charge, sometimes thunderstorm. We can see the lightning, that is also charge. Electric current, sparkles, right? So different situations. Here charge. Here we have two types of charges. One is positive charge, one is negative charge. So same charges are nothing but like charges. Different charges are nothing but unlike charges. Like means same, unlike means different. Like charges repel each other. Unlike charges attract each other. One positive charge, one negative charge attract each other. So that is the information about it. So here there is a charge. For the charge, what is the formula? Yes students, here charge denoted with capital Q or small q. The formula for charge, for example, one electron, the charge of one electron is minus 1.6 into 10 to the power of minus 19 coulomb. And C for coulomb, coulomb is the SI unit of electric current. This is the magnitude of the value of the charge of electron. And charge of proton also same value. Here for one electron charge is, this is the quantity. For two electrons, what is the charge of two electrons? That is 2 into charge of electron. 3 electrons charge, 3 into these electrons, right? So here this is nothing but charge q. So what is the charge of n electron? Charge of n electron is, that is the, let us, we are considering as capital Q, n into q. So just I am writing the charge of n electrons, n into q, nq. Otherwise charge of n electrons is ne. So we can consider here charge is E, charge of electron is E, right? Right. So Q is equals to N is the formula. Yes students, listen carefully. Here charge is nothing but, I am representing this as small q and this one is Ne or Nq. For example, charge of electron or charge of proton, whatever it may be, here number of charges N represents, Q is the charge of each particle, Q, capital Q is the total number of total charge, net charge. Okay, so this is the information about it. So formula for the formula is, so what we have here, let us see. Charge formula, SI unit, charge of electron, charge of proton, charge of neutron, right? Here formula I already told you, the Q is equals to N into E or N into small q also we can write. SI unit of charge is coulomb. And it is represented with capital C. Charge of an electron, already just we discussed, charge of electron minus 1.6 into 10 to the power of minus 19 coulomb. Charge of proton 1.6 into 10 to the power of minus 19 coulomb. Charge of neutron, there is no charge. Neutron has neutral charge. Right. We are going to the next slide. Problems on charge. For CBSE students and SSC students, here there is some problems based on charge. For CBSE it is very important, right? So problems on charge, here what are the problems on charge? Okay, this is the first question. Let us consider this question. 10 electrons are passed through area of cross section of the wire in unit time. Then find the total charge passed through it. Total charge passed through it. So here, what is given here? 10 electrons. Here these 10 electrons indicating answer or solution. What is given, children? Given 10 electrons. Here n is equal to 10. Number of electrons how much? 10. Then charge of electron E also we know minus 1.6 into 10 to the power of minus 19 coulomb. Through the area of cross section wire unit time, find the total charge passed through it. Then capital Q is equals to n into E. Substitute n value is 10 and E value is minus 1.6 into 10 to the power of minus 19 coulomb. Right, so if you multiply with 10, you'll get minus 19 becomes minus 18. So our answer is minus 1.6 into 10 to the power of minus 18 coulomb. So this is the answer, my dear students. Pause the video and copy the solution. Next, this is the question. One more question. So here, problems on charge. Question number 1 and 2. Number of charges. 5 charges, 5 electrons, n is equal to 5. 100 electrons, n is equal to 100. Charge of electron. Charge of electron E or charge of electron Q. E is equals to minus 1.6 into 10 to the power of minus 19 coulomb. And this is also coulomb, right? So here, what is the total charge? Total charge Q is equals to, we have the formula total charge Q is equals to Ne. So here n is given, here E is given. Then if you multiply, you will get the answer. So how much you will get? Multiply it and do the solution for it. This is for you. Already one has been done for you before previous slide, right? So multiply 16 5 is a multiply and put the answer 100. If you multiply with 100, 10 power minus 19 becomes 10 power minus 17. Alright, students. Okay. Next, electric current. So what is current? Current is nothing but flow. In daily life we can see some of the currents. Water currents, wind currents. Wind current means wind flow. Water current means water flow. Here water flow, water current. Flow means current. Current is nothing but flow. Flow of charges. Flow of charges through a conductor. It has fixed a particular area of cross section in unit time, right? So we can see here one of the activity. For example, this is a copper wire. This copper wire has some area of cross section. For understanding purpose only we are showing this video. Actually it was up, the conductor is up to here only. Okay, so but the conductor, how the charges are passing through the conductor, let us see. Just imagine this. So copper wire, in copper wire there is a flow of charge through the copper wire. There is a flow of charge through the copper wire. The electrons are flowing through the conductor of area of cross section A. It is in the shape of circle shape, right? So flow of electrons. Okay. So here, let me show the area of cross section. Students, here see. This is the area of cross section. Area of cross section, and the charges are moving. The charges are moving through the conductor. Electrons. Okay, so electrons are passing through this conductor. The flow of charges through a area of cross section of the conductor in unit time is nothing but the electric current. Okay, students, I hope you understood. Next, current definition. Let us see clear definition, textbook definition. It is defined as the amount of charge crossing any cross section of the conductor in 1 second. Otherwise, small definition, the rate of flow of charge through the conductor. The rate of flow of charge through the conductor is nothing but current, basic foundation. For intermediate or whatever it may be, electric current foundation, I am going to teach you. Students, copy the notes properly. The rate of flow of The rate means what here? Rate means time. Here rate means time. Flow of charge. Charge means what here? Q. Okay, the rate of flow of charge through the conductor. How much charge is passing through the conductor in unit time is nothing but electric current I. Okay, so from this what we can write, children, here? I is equals to Q by T is the formula. I is equals to Q by T is the formula. I hope you understood. I is equals to, we have the Q by T formula, and what is the SI unit? I is equals to Q by T is the formula, and SI unit of current. So once if you observe, SI unit of charge is Q, time SI unit is second, coulomb by second, 1 coulomb by 1 second is nothing but 1 ampere. So SI unit is ampere. This is the SI unit of the current, ampere, and coulomb per second also unit of the current. Okay, please write down the notes, students, then only it is useful for you. Pause the video and write down the notes. Electric current denoted with capital I or small I. Here I is equal to Q by T. Here, so we have to remember the terms. What are the terms? What we have to call this? Q is nothing but charge crossing through any cross section of the conductor. Here T is time interval, I is the electric current. 1 coulomb is equals to 6.625 into 10 to the power of 18 electrons. Note this point, my dear students, very important. Define 1 ampere. Just now I told you 1 ampere means what? Here 1 ampere is equals, let us remember the formula. Here I is equals to Q, I is equals to Q by T. I means 1 ampere. 1 ampere is equals to charge unit is coulomb, 1 coulomb by 1 second. So what is, how to define? That is in equation format, okay. But how to define this? An ampere. If 1 coulomb of charge passed, already we discussed here, 1 coulomb of charge, 6.625 into 10 to the power of 18 electrons, crossed unit of cross section area in 1 second time. ఒక సెకండ్ లో 6.625 into 10 to the power of 18 electrons pass అయితే ఒక సెకండ్ లో, then it is said to be 1 ampere current. I hope you understood, children. 1 coulomb by 1 second, right? So remember this. Okay, next, potential difference. What is mean by potential difference? Here first let us see the definition. Potential difference formula. Here potential difference V is equals to W by Q is the formula. Okay, so W by Q, here it is a work done upon unit charge. Work, W for work, Q means charge. Work done on unit charge. ఒక యూనిట్ ఛార్జ్ పైన జరిగే వర్క్ నే మనం ఇక్కడ పొటెన్షియల్ డిఫరెన్స్ అంటున్నాము. లెట్ us consider this is the one of the charge. Here work done, what is the formula for work done? Work done, W is equals to force into displacement. Here on the charge force should be applied and it should be displaced some distance. Yes, okay, so force apply చేయబడాలి, ఆబ్జెక్ట్ కూడా డిస్ప్లేస్ అవ్వాలి. Here object should be displaced. Force should be applied and object should be displaced. Here force is applying and object should be displaced from A to B. So what is the definition? First let us see the video. Alright. See, now force is applied on the charge. It was shifted from A to B. It was moved from A to B. Alright. So now it is considered as potential difference. See once. Here now charge was shifted from A to B because of force, electric force. So now charge was shifted from A to B by shifting charge from one point to another point. Work should be done. That work is nothing but F into S. Force should be applied. Displacement is there on charge Q. So here W by Q is nothing but voltage V. Okay, I hope you understood. Go to the next slide. Here the definition. Potential difference, it is denoted with capital V. Definition: work done by the electric force on unit positive charge to move it through a distance L. Distance L or displacement S from A to B is called potential difference between those points. Very important definition, my dear students. Pause the video and copy the definition. Compulsory should write the definition, otherwise no use. Okay, how many times you will see no use? Write the definition, write the notes, entire notes, then only it is useful for you. A formula and SI units just now already we discussed, right? So what is the formula? Here the formula V is equals to W by Q is the formula, and the unit also W unit is work unit is joule and charge unit is coulomb. Joule by coulomb is a unit, and also voltage unit, potential difference unit is volt. Volt is the SI unit, and 1 volt is equals to, here 1 volt is equal to 1 joule by 1 coulomb. Next, here EMF. Next slide is EMF, electromotive force. Here both are similar, చూడడానికి ఒకేలా ఉంటాయి. Potential difference and electromotive force. What is the electromotive force? Here electromotive force also, this is the amount of work done. It will shift to charge one point to another point, but this is due to electric force, not electric force. This is due to chemical force. This is due to chemical force. Here chemical force do the work. Chemical force do the work from A to B. So this was we can see in the battery cells, we can see it, right? So here the same thing. In battery, positive terminal, negative terminal is there, right? So one terminal to another terminal, the chemical force will shift to the charges, whether positive to negative or negative to positive, students. Okay, so once you see here, these are the two plates, the positive plate and negative plate. So there is one electron here near the negative plate, there is one proton near the positive plate. For example, if you consider the first definition, negative charge to move from positive to negative, here there is negative charge. To move negative charge from positive to negative, why? Because in the battery, chemical force, chemical energy will do this one work. It separates the same polarity. నెగిటివ్ చార్జెస్ అన్ని ఒకే ప్లేట్ పైన, పాజిటివ్ చార్జెస్ అన్ని ఒకే ప్లేట్ పైన సపరేట్ చేస్తుంది. సో ఇక్కడ నెగిటివ్ టెర్మినల్ అనేది ఇక్కడ ఉంది, నెగిటివ్ చార్జ్ ని అక్కడికి తీసుకెళ్ళాలి. సో కాబట్టి ఇక్కడ వచ్చేసి పాజిటివ్ చార్జ్ అట్రాక్ట్ నెగిటివ్ చార్జ్. సో హియర్ ద అమౌంట్ ఆఫ్ వర్క్ డన్ టు బ్రింగ్ negative unit, negative charge from positive terminal to negative terminal, right? Work done by the chemical force on unit negative charge to move it from positive terminal to negative terminal of the battery, otherwise or positive terminal, positive charge from negative terminal to positive terminal of the battery. Work done by the chemical force to move unit positive charge from negative terminal to the positive terminal of the battery. I hope you understood. So this is nothing but electromotive force, EMF. Pause the video and copy the statements. Next, here the SI unit is also volt. EMF unit, SI unit also we have volt, students. So what is mean by 1 volt? What is mean by 1 volt? What is mean by 1 volt means whenever you get 1 volt or 1 ampere, simply you write the formula, voltage formula, W by Q. Already we have done this. Here V means volt. 1 volt is equals to, just you write down 1 volt is equals to W for energy, unit is joule. 1 joule by Q means coulomb, charge unit is coulomb. So based on this we can define how to convert this expression into statement. If 1 joule work has been done on 1 coulomb charge, then it is said to be 1 volt. Okay, so it is a ratio of 1 joule to 1 coulomb. If ఒకవేళ 1 joule work జరిగితే 1 coulomb పైన, దాన్ని మనం 1 volt అంటున్నాము. Students, you go through the definitions, follow the textbook. Right, next, Ohm's law, experiment. Okay, So this we will discuss in the next part, Ohm's law experiment, and next resistance factors affecting resistance, and we have series parallel combination problems, discuss Kirchhoff laws, and we have the problems based on power, functioning of fuse, and everything we'll discuss. All right. So I hope you understood subject. Support our channel, like and share to other students also. It will helpful to you others. So I am doing the work for you, right, children? So share to your friends. Signing off. Bye bye.